Lesson 70, we're working with direct variation problems. It's really an extension off of Lesson 69, which was dealing with the same type of problems, but today we're looking at more real-world application examples. We'll start with a little review. Direct variation. Can first of all be found by doing a couple of different methods. Number one, we could use proportions. We could also use the equation format, which the equation, again for direct variation, is y is equal to some constant k times x. If we go back to our previous example, total pay varies directly with the hours worked. We see this phrase varies directly and we automatically know right away that that is a direct variation problem. And again, the way we like to set it up is y is equal to some k times x. We'll understand in this scenario the total pay is playing the role of our y in this scenario. And the hours that we work, well, that's going to play the role of your x. So let's go capital or lowercase h for the hours that we work, and then we'll take that times our constant k, which is the amount that we get paid per hour. Therefore, if we wanted to figure out our total paycheck, and we knew that we got paid $10 an hour, and we worked an 8-hour day, 10 times 8 would tell us that we get a total pay of $80. Example number one, the amount Ellen charges for food varies directly as the number of people that attend. So we know right off the bat that this is a direct variation problem. If Ellen charges $780 for 60 people, we want to know how much does she charge for 100 people. Let's talk about our first method that we can use to solve this one, setting up proportions. If we look at our two categories that we have here, we have cost, and then we have the number of people. So if we look at the first scenario, we started by stating that we charged $780 for 60 people. And really what we're going to do is we're going to set up scenario number two, where we want to know how much does she charge for 100 people. So we know that there is 100 people, but what we don't know is how much we charge. And that's what we're going to solve for, is that variable x. Therefore, if we cross multiply 60 times x, we'll get a 60x. 780 times 100, we'll get a 78,000. And now we solve for x, therefore we divide both sides by 60, and we come up with 1,300. Now I want to talk about method number two using the equation real quickly. Recall the equation is y is equal to some k times x. So understand for this scenario, the role of y is now the cost, and the number of people that we have is now playing the role of x. Now what we really want to find here is the cost per person. Because if we know how much we charge per person, then obviously we just have to take that amount and times by however many people are going to show up. So how do we find that? Well, if we go back to the beginning, we said that the cost was $780 for 60 people. So through simple division, if we take 780 divided by 60, I will save you a little bit of time, you will find that to be $13. So after doing this, we know that we're going to charge $13 per person. So we need to take that $13 times however many people are going to show up. If we go back to our equation, C is equal to K times N, the total cost is what we're going to solve for. Our constant K is actually that $13 per person that we just found. N, again, is the number of people that are going to show up or attend, which was 100. And if we solve our equation, 13 times 100 gets us 1,300 again. Example number 2, driving at a constant speed. Maggie travels varies directly with the amount of time she drives. If Maggie drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? For this one, I'm not going to go through both methods, but instead I'm going to use method 1, setting up proportions. Now, if we look at the first scenario, 75 miles in 1.5 hours. So my two categories, my two things that I'm looking at here is my miles, which is the distance, and then I'm also looking at my time, which is hours. So for the first one, we went 75 miles in 1.5 hours. So you could write it that way if you wanted to. You could also use your decimals, and that's okay, 1.5. Lastly, we want to know how long does it take for her to drive 100 miles. 100 of the miles was up in the numerator. That's why it's helpful to put the miles over hours on the left-hand side. And what we want to solve for is the amount of hours that we have. Again, if we cross multiply, 75 times x is 75x, which is equal to 1.5 times the 100, which will get us 150. And we know that we need to take 75 times 2 to get that 150. So it works out pretty well in this one where it came out to an even 2 hours. Lastly, 23 people in front of Debbie waiting to be helped. 3 minutes later, there are now 18 people in line. We want to predict how much longer it'll take Debbie to be waited on. Okay, so first of all, we started with 23 people ahead of us. Now we're down to 18. So obviously that meant that 5 people have gotten through the line within those 3 minutes. So what we want to do here is we want to find the number of minutes it takes per person to get through the line. So in 3 minutes, again, we were able to go through 5 people. And if we do our division, 3 divided by 5, that's the decimal 0.6. And what does that 0.6 represent? Well, it represents the number of minutes that it takes per person to get through the line. Now we could change this minutes to seconds because it is a decimal. That would make sense for us to do that. But we're actually going to keep this 0.6 the way it is. Because if we look at our equation, and the equation y is equal to k times x is going to look like this. W is equal to that constant k times the number of people ahead of us. So how long will we have to wait? Well, my constant k is the 0.6. The number of people that have surpassed in that time, or that are left, are 18. So 0.6 times 18 gets me a total of 10.8 minutes. And understand the problem was approximately, or predict about how long it'll take. So we're going to go ahead and say approximately 11 minutes. Now there are other ways to go about this problem. This is not the only way. If you would like to use proportions, feel free to do so. Otherwise, what I would like you to do is go ahead and attempt the practice set problems A and C.